Okay, so this session I'll be continuing with the Cusum control charts. As I've already mentioned that when you use a Cusum control chart, you need to use certain decision rules. So what are these decision rules? If suppose the target value of the process mean is mu0, and if you find that the Ci, that is the cumulative sum at the ith sample point, the way you have computed, has random fluctuations with mean at 0. So this will be your observation when the process is in control at mu0. If the process has gone out of control and there is an upward value, upward trend, and reaches mu1, then Ci must show an upward or positive drift. Similarly, if there is the process mean shifts downward, that means the Ci must show a downward or a negative drift. Is it okay? Now there are two important schemes we have referred to. What are these two schemes? The first one is referred to as the tabular or algorithmic Cusum, and the second one is the BMAS template. Now let me explain the details of the tabular or algorithmic Cusum. Is it clear? So this is widely used. This particular the scheme you can use. So let me explain it. What are the steps involved? Okay, there are certain steps involved in order to use this particular scheme. Supposing xi is the ith observations of a process. Okay, obviously with respect to a particular quality characteristic. Xi may be a normal random variable. Is it okay? In many cases, there is a physical basis of assuming that the output of a particular process is normal. So supposing x is the output for a particular process, okay, output or the response variable. So you may assume it to be normal random variable with mean mu0 and the standard deviation sigma. Is it clear? So whenever you have the data with you, so you can have an estimate, is it okay, of mu0 and an estimate of sigma. Mu0 may be referred to as the target value. Is it okay? So the mu0 is your target value, that is the mean. We used to monitor the process mean, that's all, right? That means you need to use a control chart for controlling the process mean. So that is a very important assignment. That means whenever you start using a control chart, you must specify the specific the process parameter. Is it okay? So in this case it is a process mean. When the process drifts, that means when the process drifts, you assume that due to many reasons there could be the change in the process mean values. The Cusum signals and an adjustment may be made. That means what is the signaling? That means if you use the Cusum control chart, that means and at a certain point in time, suppose the process mean, there is a change in the process mean. Now this Cusum will be sending a signal, and looking at the signal, you may assume that the process has gone out of control. Now what you do? That means you want to run the process at a particular value, that is mu0. So this is acceptable to you. So what you need to do? That means an adjustment may be made in the manipulatable variable. Is it okay? It's a typical, the chemical industries. Is it okay? So there is a manipulatable variable to bring the process back to target. That means you have a thorough knowledge about the process. That means what are the factors affecting the value of the output variable. Is it okay? So, and then what you try to do, if suppose you do not get the value of the output, is it okay, at the target value, at the target. So you must be able to identify the manipulatable variable. Is it okay? And you change, try to change this manipulatable variable, that is the input variables, in such a way that the process is brought back to the target value, or the Cusum signals to an out of control condition and the presence of assignable causes in the process. Is it clear? So this, as you observe, that when you start plotting the CI values over the samples, so you will have these sort of observations. Okay. Now, what do you try to do? That means while you compute CI, now there could be positive deviations, there could be negative deviations from the target. Is it okay? Depending on what is the actual value that you are getting in a sample. So accordingly, you can form two types of statistics. The notation is C plus, okay, superscript, and C minus, superscript. So this is basically the positive deviations, it indicative of positive deviation, and this is the negative deviations. So what is C plus? Accumulated deviations from mu0 that are above target. Okay. So sometimes this is referred to as one-sided upper Cusum. It's clear? So what is C plus? This is the one-sided upper Cusum. What is it? Basically accumulated deviations from mu0 that are above target. It's clear? What is C minus? Okay, superscript minus accumulated deviations from mu0 that are below target. That means some of the values, they will be greater than mu0, and some other values in x, is it okay, they will be less than mu0. Is it okay? So you create C plus statistic under these conditions. This is referred to as one-sided upper skew. And again you create, you have this C minus statistic, which is referred to as one-sided lower Cusum. Is it okay? So it is breaking down into two. Okay. Okay. Now, next what you do, that means you develop a scheme. So you define C plus as maximum 0, xi is the actual value, minus the mu0. That means xi is greater than mu0. And what is k? That means you add this allowance. Is it okay? So that is very, very important, right? That means before, that means some allowances is to be given so that the process remains under control. It may be heading towards an out of control situation, but before you reach there, you must be able to take some preventive measures or corrective measures. Is it okay? Because once it crosses the beyond the target value, that means already it has gone out of control. Is it okay? So you can't take any corrective measures. Is it okay? So as we have been telling you that this is an online real-time control. Is it okay? So obviously there must be some allowances. So this k is essentially the allowance that you have to specify, and this is for the ith one. Is it okay? So this is for the I, C plus I, and this is related to C I minus 1. So this is subscript will be Ci. Is it okay? So you write it here I, and similarly the negative deviation, that means Ci minus, is it okay, which is related to the previous one, that is Ci minus 1. Is clear? So this is 0. That means if it is negative, suppose for some reasons it is negative, obviously it is made 0. Similarly here, that means first mu0 minus k, that allowance you subtract, and then xi value is always be expected is less than mu0. That means those values of xi which are less than mu0, so that those values form a different set. Is it okay? Set of values. So this is Ci minus equals to maximum 0 of this one. That means this is if this is positive, if this is negative, it is converted into 0. Is it clear? So either 0 or positive value, that is to be ensured. Is it okay? So please go through these equations. I am sure that you will be able to understand this one. That means ith value is related to I minus 1th value. Similarly, I minus 1th value is related to I minus 2th value. Is it okay? So this way, all these the individual values, individual sample values are related. Is it okay? Now, what is k? I have already mentioned. K is the reference or the slag value or the allowances. So three names are given. That means k is referred to as the reference value, or it is sometimes referred to as the slag value, or it is referred to as the allowances. Okay. If mu I, mu1, I have already while I explaining the decision rules, I have referred to say the mu1. So mu1 is out of control mean value. That means you have specified. Suppose the mean value is originally when the process is controlled, suppose the mean is 10 and suppose the sigma is 1. Sigma is 1. Now what we are assuming now that the sigma remains same. Suppose we are assuming that the sigma doesn't change, but there is a possibility that the mu may change. So suppose mu changes to from 10 to 11. Is it okay? So that is the value of mu1. And you say that if it changes to 11, the process is assumed to be out of control. Is it okay? There is an upward trend. And similarly, you say that if the value of mu changes to 9 and this is considered to be a significant change, the sigma remains same, but I will say that even mu equals to 9 is not acceptable, but this is the downward the drift in the process. That's why it has become 9, and that may be the value of say the mu2. Is it okay? So mu1 is the out of control mean value that is to be detected. So you must have a thorough knowledge about about the data that you generate. K may be chosen as the midpoint between mu1 and mu0. That is the norms, okay, unless otherwise specified. So it is the mid value that is considered to the allowance. That means as soon as the value crosses the midpoint, the process is in control, but you be careful about the process condition, and you must know immediately that why it has crossed this midpoint. Is it okay? Is there any, is it heading towards a value called mu1, and then the process will be going to out of control condition, and then obviously there could be unexpected bad performance from the process. So that is to be avoided. So the target value is mu0 and out of control mean value is mu1. So mu1 is equals to mu0 plus delta into sigma. Is it okay? And this is the deviation in terms of sigma. I have already mentioned that the deviation is always expressed in terms of sigma. So what is the value of k? Obviously delta by 2 into sigma. That means mu1 minus mu0. That is the difference between mu1 and mu0, the absolute value, and half of that. Okay. So what is the decision rule? That means with the given set of data, okay, you need to compute Ci plus or Ci minus. What is I? I is the sample one. That means suppose you have some 20 such sample points or 30 such sample points, and say you have to start from I equals to 1. You have to calculate Ci plus, Ci minus, okay, both by using this the two formulae, and then you continue this exercise. Is it okay? That means from the first period you go to the next period, the time wise. That means in each period you get one sample. Okay, that is the assumptions. The time wise you do. So what is the decision rule? If Ci plus or Ci minus becomes greater than the decision interval h, this is very, very important. That means you are controlling the cumulative sum of the deviations from the target at a particular point in time. Is it okay? And it is continuing. Is it okay? So as you are taking the cumulative deviation, cumulative values, so obviously even if there is a small shift, now at a certain as it is a cumulative calculation, so that's why even if the small shift, okay, maybe maybe signaled as a prominent one, at a particular value of I or the sample point. So this is the basic idea, and then you check at a certain point in time, okay, or at a certain sample, whether this the Ci plus or Ci minus is greater than H. And if you find that this condition holds, then immediately you assume that the process is assumed to be out of control. Is it clear? So with the given data set, what you need to do, you have to calculate for any sample I, Ci plus as well as Ci minus. And there must be some initialization condition, and you assume that the Ci plus and the Ci, that means this is C say 0 plus and C0 minus will be 0. So this is C0 plus is equals to C0 minus will be 0. Is it okay? That means the starting is 0. Or you may have some initialization condition if is known, so that you can add. Is it okay? That value you may consider, not necessarily 0, but usually it is 0. So at certain value of I is a particular sample point, you reach these conditions. Okay, so process is assumed to be out of control. Otherwise, you say that the process remains in control. Selection of the values of K and H are very important. It is obvious, in fact. That means, as such, there is no mathematical formula, okay, for determination of K and H. But the certain, so the based on your experience, okay, if you refer to several case studies on this, so the researchers, they have prescribed certain value. Is it okay? Certain expressions for K, certain expression for H. Is it okay? So, so at the initial stage, why don't you assume those values? Is it okay for K and H, right? So usually H may be assumed to be 5 times standard deviation. So this is this value, that means H may be assumed to be 5 times sigma. Is it okay? Cumulative, right? So if this is the norms, so there must be some basis. That means researchers, based on their experience, based on their investigation, they say that this is these assumptions may be assumed to be valid in most of the processes. Is it okay? So H is equals to 5 into sigma. So what we are assuming at this stage, that the sigma doesn't change. The sigma remains constant. That means you have taken the steps, adequate steps for controlling the variability, and that is the precondition always you said. So just make a note that whenever we carry out such exercises related to control charting, so the first conditions you have to meet, so whether you are able to control the variability. Is it okay? As I have been always telling you, that any exercise is quality is essentially is a quality on is an exercise on variability and exercise on consistency. Is it clear? So once the necessary condition is met, obviously you will be you are in a position to use such a scheme called algorithmic Cusum. So with the given data set, so every data set, what is the data set? That means related to a particular sample or related to a particular time period, you have all these X values. Is it okay? And what is this X? X refers to a particular quality characteristics. Why you are referring to a quality characteristics? Because we are referring to a process, and this process is essentially you use to produce these quality characteristics. Is it okay? So quality statistics is obviously inbuilt in the component or the part. Is it okay? So so that part processing or the component processing you do using that particular process. Okay, and for that particular process you are going to create this Cusum control chart. Okay, with a given data set we construct the following table. These are actually the table format. I am not showing the table. Later on when we take up the numerical problems, is it okay, you will refer to the table format. So in the table what you have the several columns. Is it okay? So so for using say algorithmic or tabular Cusum, what you have to do, you have to create this table. Okay, so in the first column you refer to the period, that is I. In the next column, that is the second column, you have the corresponding value of the quality characteristics. That means for the ith sample or the ith period, is it okay, what is the value of x? So x is a variable. Is it okay? Now you have, there are what you need to do, that means against xi you need to calculate the ci plus as well as ci minus. Is it okay? So against ci plus you have 3 columns. Is it okay? So this is part small a, and against say ci minus, is it okay, that also you are going to compute against xi. You have 3 columns we have. Is it okay? And this is a subset of the columns they refer to as the B. That means you have one section A and another section B. So under section A, what you compute actually, mu0 will be known, xi value is known. So against a particular period, okay, for a given period, you can calculate xi minus mu0 and k will be specified. How do you specify the k? That means you have defined mu1. Is it okay? Mu0 is known. So is the midpoint between mu1 and mu0. Is it okay? Unless otherwise specified. So that is the value of k, and the k is the allowance or the slack value, right? So this is the first column you have. Is it okay? Against each value of xi you have to compute this when k is known, when mu0 is known. Then ci plus, that means what is the cumulative value. Okay, so suppose the first value is 0.5, okay, and the next value is say you calculate say 0.5 again. So at the first stage, that means when I equals to 1 it will be 0.5, and the next stage it will be 0.5 plus 0.5, that means 1. And in plus means, that means it indicates it's basically a counter of what? That means counter of the positive deviations. So suppose the deviation is positive, that means it will be 1. Now the next stage, suppose the deviation is again positive, so it will be 2. At the third stage, suppose it becomes 0. Is it okay? Suppose the third stage you get the value of xi in such a value that it becomes negative, and negative is converted to 0. So obviously again the counter, that means cumulative, will go. That means third point it will be 0. Is it okay? So again from the fourth the sample point onwards, or the fourth time period onwards, you need to count the n plus values. Okay, so this is the first part. And similarly, when you need to compute the ci minus, so ci minus, the mu0 is known, that means it is the negative deviation, and the negative deviation is converted into the positive one, like this. So xi is on likelihood is less than mu0. Is it okay? So you subtract minus k, that means suppose this is 0.5, this is say the 10. So 10 minus 0.5, that will be 9.5 minus the actual value. Is it okay? Whereas if it will be, say, the actual value minus say 10.5. So the actual value will be will be, you will subtract 10.5 from xi, whereas here the actual value will be subtracted from 9.5. Is it okay? And cumulatively you do. And similarly, you will have this cumulative value, that is Ci minus. Is it okay? So, and then the number of counters. Is it okay? So, number of the times you will have the positive values. Is it okay? In the deviations you will. So, this particular table you have to construct. Is it okay? Again, I am telling you that when we take up numerical examples, so this table will be constructed with respect to a given problem, numerical problem. Okay. So, what is n plus or n minus? Number of consecutive periods with Ci plus or Ci minus greater than 0. That means the positive values. Are you getting my point? So, as soon as it becomes negative, it at that point in time it becomes 0. Is converted into 0. The way we use the formula, we have derived the formula, we use that formula, and then again you start from 0. That means the chain is broken. Whenever at a period, now this point you please go through. The first thing is that whenever at a period, say time t, is it okay? Or say say the ith time period, ith sample, we find Ci plus or Ci minus, like Ci plus and Ci minus greater than h. What is h? H is 5 times sigma. Okay. What is sigma? Sigma is the process standard deviation. Now, if these conditions at a particular, the sample at a particular time period, you observe that this condition holds, we conclude that the process is out of control. Okay. So, that is the norm we follow. And by referring to this value of n plus or n minus, that means how many consecutive time periods you are observing positive deviation. Are you getting my point? So, that is very, very important. How many consecutive time periods, that is n plus or n minus. Okay. Now, when you refer to this value, say 5 or 6, if it is 5, that means it means that 5 consecutive time periods you have positive deviations. And as you are dealing with the cumulative sum, obviously these over the time periods for which you get the positive values, these values will be increasing. Is it okay? Now, at a certain point it starts increasing, and if it crosses the value of h, immediately you conclude at that point in time that the process has gone out of control. Is it okay? So, that time you conclude. But the question is that the trend has already occurred. That means it's not necessarily that when you observe or when you conclude that the process has gone out of control, at that point in time or for that sample, you are observing, it's not necessarily mean that that out of control condition has occurred at the same the sample point. So already the out of control condition has occurred some the previous samples. So you need to identify that particular sample or that particular time period. You have to identify where possibly the out of control condition has occurred, and then due to existence of some assignable causes, so that particular sample point you have to identify. So by referring to this value of n plus or n minus, we can identify the period when the process is in control. Is it okay? So this is the point to be noted. You have to identify. Is it okay? It's like you are referring to the past data, and you just going to check that at a particular sample or at a particular time period something has occurred in the process behind the scene, and you have to identify those possible the causes. So the process is in control, and the shift in process mean occurs during this period and the subsequent time period. Is it okay? That means what has happened, suppose you find that on say 20th sample point, is it okay, there is a value of Ci plus has crossed say each value. Now you check that n plus. You find that the value of n plus is 5. That means what do you conclude? That 20 minus 5, that means the 15th point. Is it okay? Possibly in the 15th point, okay, that something has gone wrong, and the process has gone out of control and it is continuing. Is it okay? So between so the 14th and the 15th sample, up to 14th it is an out of control point, but the 15th sample point onwards, you may assume that the process at 15 point onwards, the process is out of control. So something has happened between say the 14th point and the 15th point. Is it okay? So you have to refer to the past data, and you have to find out, as a process engineer, as a process control engineer, say, or executive, that what has gone wrong. Is it okay? Between the 14th period and the 15th period. Okay. So we need to look into the possible assignable causes and take remedial measures to remove these causes. Is it okay? So this is the reason, and what we have observed that that the tabular algorithmic Cusum is a very reliable tool, and the way the scheme is developed, you will come to know three things: whether the process is in control or not. Second thing is that even if the shift magnitude is very, very small, and that normally this happens for a sophisticated process, very quickly you will be able to detect that. That is the second, so the aspect we must look into. And the third one is that you will observe at this point in time that the process has gone out of control. But at what point in time actually the out of control condition has set in? So you will be able to identify that particular the time period as well as the sample point, so that the kinds of actions you take, kinds of the remedial measures, or sometimes the preventive measures you take to eliminate the assignable causes in the process. So that will be very, very the specific, and the solutions will be getting, that is highly reliable. Is it okay? Because exactness will be there in your solutions approach. So Cusum status chart is normally plotted. That means a plot of Ci plus and Ci minus. Is it okay? This is the positive deviation and this is the negative deviation. On the positive direction and the negative direction, values over time period shown as a horizontal line in both the zones. That means you have a horizontal line, that is a 0. So positive deviations are shown with Ci plus, and the negative deviation, that is Ci minus, over the time period. So this is basically referred to as the Cusum status chart. So the changed value of the process mean can be estimated, like, so this is the change value. So it was mu 0, then the allowances Ci plus divided by n plus. So if Ci plus is greater than h, and mu 0 minus k, that means on the other side. Is it okay? That means this reflects the upward drift and this reflects the downward drift. Is it okay? So in both the cases you will find that the Ci minus or Ci plus is greater than h. An adjustment needs to be made in the value of the relevant controllable variable to bring the process to its target value mu 0. So whatever may be the current value mu1, it is not, or mu2, it is not acceptable to you. You must be able to bring it back to the original value or the target value, that is the mu 0. So in many cases, once you refer to the case study, you will find that to bring back the value to mu 0, you need so the engineering aspects you have to look into. That means an engineering solution is called for. So with this, I conclude my discussions on algorithmic Cusum. So the other charts we will be discussing in subsequent sessions.